full screen? Awesome. Morning, everyone. Hope you're well. Um, Morning, everyone. Hope you're well. I see the people at the back are saying I should speak louder. Thanks. So I'm actually here on behalf of my colleague, Tao Makhaile. He's our systems administrator. He couldn't unfortunately be here, so he asked me to be in place of him. So I am by all means not the expert in OpenStack. So if I say something wrong, you can take me at the back and bludgeon me. It's fine. It's out there, so the pool of blood is not here for the next speaker. Um, so um, there we go. As Dora said, I'm part of geospatial modeling and analysis. We are a sister group to Nikki's in the same division, NGEI. And they said yesterday we should invest in AI. So I used ChatGPT to make that picture sort of getting there. So GMA, we do these services. Our biggest and longest standing one is Advanced Fire Information System, or AFIS. We monitor wildfires throughout the world. We also do some geocoding, water quality modeling, in charge of some land cover codes. Last year, we expanded into the space of community safety. And this year, we're expanding into the medical field. We're doing exploration in TB and HPV research as well. So this is, here's some of the software that we use in the group. The point is we use a lot of software and we need to get it out there to people and package it using scalable technology. And this is where our system administrator sold us into the idea of OpenStack. OpenStack, what is it? We've already seen two examples actually that are used on OpenStack with the previous speakers, so thanks for that. And we are now coming on board with it, but let's go a bit in depth. So it's open source. It's considered infrastructure as a service, although it's a software. You put the software onto your infrastructure, and then you have this as an infrastructure as a service. It's basically used to manage and automate your computing resources as well. It was created in 2010, so some time ago. What is it? What is its core features? Basically scalability. Think about easily creating virtual machines and then assigning various amounts of RAM, CPU, and space and networking attached to those virtual machines. It's very, very flexible. You can incorporate many other types of softwares into this and basically run anything you want. Cost efficiency, it's open source, no cost attached. It's also community driven, so if new infrastructure comes out, very likely the next version of OpenStack is going to support it because of the wide world community developing in this. It's also quite user friendly. I've used it myself a little bit. You just click buttons most of the time, which is quite nice. So how does it actually work? You basically install this on top of your infrastructure, and that allows you to then tap into those computing resources. It's mainly built for Linux. I suppose some of you clever people here could hack it for Windows. But how it works is it has a lot of components that does the certain jobs for the specific. For instance, creating the virtual machines, it uses Nova. It has networking, data storage, attaching and detaching your hard drives, or virtual storage rather, and a nice interface. But I won't go into that. There's a full list over there, and you can go check that out. What is its actual benefits? It's quite agile. You can basically create a virtual machine, install your software, and that's it in a matter of minutes. It's very customizable. We in research and academia, so we can tailor our needs for that. but businesses might have a different need, so they can tailor their computing resources as such. It's also quite interoperable as well with other platforms. Um, there's a couple of use cases there. For us specifically, we are focused on high performance computing for research and academia, and managing DevOps and full stack development as well. OpenStack's used for many organizations around the world. CERN stands out over there because CHPC does support them as well. They also use OpenStack. You can check out the list in that link there. So CHPC has adopted OpenStack in the past couple of years to enhance its infrastructure, basically. They started off, according to my research, this is a moment where you can take me to the back and bludgeon me, with this to support the square kilometer array. And then they later deployed it to the private cloud, and that gave access to everyone else as well, which is quite nice. So yeah, they deployed it around 2020, and that basically empowered many researchers and upcoming businesses and startups. So the direct benefit for the CHPC itself, basically advanced the research collaboration, a lot of support for DevOps and full stack development, such as our project AFIS at the moment. You can then provide high performance computing simulations, or the infrastructure behind that very quickly. And also human capital development. You can teach people many things about higher performance computing with just a simple interface. Now we've looked at what was good for why OpenStack is useful, why it's useful for CHPC, and now why is it useful for me and you as the end user. So we don't have to depend on our own servers in-house. All of the infrastructure sitting at the CHPC. That means the risk is basically slashed in half or even more, because the risk is now only on our software side. There's no cost attributed for us to now upgrade our own servers and UPSs, etc. That is unfortunately on CHPC's side. And we also don't have to then constantly upgrade our operating systems, as well as the OpenStack software itself on our servers, for instance, or on CHPC servers as well. And yeah, it's a very easy interface. I learned it in a day. It's a bit of a tiny steep learning curve at the beginning, but once you get the hang of it, it's pretty easy. And yeah, it's very quick to give people access to the virtual machines as well. When we deployed a few things, websites, there was no difference in speed in terms of accessing those websites as compared to running it on our local servers as well. So in fact, it might have been faster, so even better. And of course, I can work anywhere in the world. I just need an internet connection as well. There are also, with many blessings, there is challenges to get to those blessings. As I mentioned, the tiny learning curve. The other one was the networking. So this is now specifically, how do you map the traffic of data between the virtual machines, as well as within the Docker containers within the virtual machines, and within Docker containers between the virtual machines. So sometimes you got to use the DNS, sometimes you got to use the IP address. It gets a bit confusing if you are not accustomed to networking and DNSs. So, and also the last thing, if CHPC needs to do maintenance, unfortunately, sometimes the system would go down at that point in time. But at least the CHPC is very good. They send out the emails, and then we can actually provide for the downtimes as well. So this is what it looks like, the GUI, the front-end GUI. So you're looking at our computing resources there. You can then see your entire distribution of computing resources, what you have already used, what you can use, and still distribute. These are some of the virtual machines we have. You'll see there's our AFIS data feeders because we're porting our AFIS systems now to OpenStack. There's our data feeders, database, AFIS viewer, load balancer, etc. We're still busy with that. And you can see how we distribute the resources there as well. And the nice thing is, if for instance the hard drive or hard disk space gets used up, we can just attach extra space onto that virtual machine. As simple as that. For every virtual machine, you have that little button over there, and that button allows you to basically configure that entire virtual machine over there. And the other nice thing is you can add your own operating system images. For instance, if you use a specific version of, for example, GDAL or some other library that you need to be built, you can build it on an image, and then you can save it here. And then whenever you make a virtual machine, you can just use that as the base image. So it's pretty convenient. The other nice thing is with the networking, you can actually put in networking groups. With those groups, you can then assign specific groups to a specific virtual machine. So in other words, you can hide all your virtual machines or specific ones under your company's network or VPN. So for instance, all of our VPNs are hidden behind the CSR firewall so that no one else can access them. Or you can make a virtual machine open to the world, and you can then access that one. Yeah, this is just to show you how you can literally drag and drop the network you want. So GMA VPN that you see over there, that's to hide our virtual machines under the CSR network. There's documentation. You can go check it out. It's pretty good. And then something quickly about AFIS. This is a system that we are porting over to OpenStack. It's been running for the past 15 years since it was created. And we have archived fire data for the last 20 years also on hand. I joined in here about 5 years ago, and now I'm running the AFIS project. So if you need to speak about AFIS, you can approach me. So we're getting there to shift all the components of AFIS over to OpenStack. It's a big system. Go. And hopefully it's quite easy because we have everything containerized in Docker. The only thing was the network thing. I'm not a network person, so I just still need to figure out IP addresses, DNSs between the components. Just to show you quickly in a basic schematic what we are doing. So you see there's our satellite data coming through. That's out of our control. We have our data downloaders, data processors, database, GeoServer, load balancers, the entire viewer on our servers at the moment, which is getting old. So we're happy that OpenStack is available because we are shifting all that stuff under the blue bracket into OpenStack. And that reduces the risk completely. So 1 week ago from today, this was the fire situation in South Africa. So you can go check it out on AFIS. It's a free product, afis.co.za, and you can go sign up there to see what's the fire status around the world, actually. So I have a bit of a challenge for you, just to make it a bit more interactive. So if you have a pen or if you want to roll up a paper or something like that, um, it's a little party trick. So if you put your hands together and the pen between it, between your thumb and index finger, can you get to a state where your palms are facing outwards, but the pen is still in the middle of your thumb and index finger? But the trick is, and there's a rule, you cannot take the pen away from the middle there. So you cannot go around the corner to get to that state. So if you can do that, then that's great. If you can't, then you have to sign up on AFIS. So, I'm not going to give you the solution now. You can approach me outside and then I'll show it to you. But you have to show me proof that you signed up on AFIS. Okay. So I want to say thank you very much to our chair, Dora, to the other presenters as well, that I could also be among you today, to the audience for listening and your attention, and to our lifesaver, Tao Mahaile. Whenever a system goes down, I call him. And to the CHPC specifically because they sponsored my travel and accommodation and gave us resources on OpenStack as well. And I invested again in ChatGPT. Unfortunately, we are not esteemed, we are esteemed. We're getting there. We still need to invest a bit more. So here's my contact as well as my system administrator. You're welcome to contact us. But if you want OpenStack stuff, you'll have to contact the CHPC. I can't give you those resources, unfortunately. So yeah, I can take questions, Chair. Oh, and you can't ask how to get from here to here.
Okay, let me make this small disclaimer. I am from Eswatini, so I'm not from South Africa. So you kept reference of CHPC. When CHPC is down, things are not happening. So what is CHPC in this context which you are talking about, and what do they provide you with? Yeah, I think if
Okay, so CHPC, Center for Higher Performance Computing, and what do they provide me with? They provide our group with computing resources, basically. So they provide us with infrastructure as a service. So we have a lot of data processes. We download data from satellites. We process it. That's very intensive stuff. So we can then section that specific part off in its own virtual machine. Then from that, we can take the data and put it into a database, and that database with its services is in its own virtual machine as well. I'm not sure if I'm answering your question.
okay, I'm just asking in terms of infrastructure that so you have a relationship with CHPC,
Yes.
a marriage, is it for a lifetime, or because I was of the thinking that for the high performance computing, you have your own setup, you just visit them for computing resources, you don't stay there for long enough. Maybe I'm even thinking about it like the Amazons,
Okay,
where you rent and go.
okay.
Yeah. This.
I think I get you now. So let's say because we are sister groups, I am privileged. So we all part of CSIR, and we get I'm not sure how the funding model works. I think we get like a discount or something because we are a group based in the CSIR as well. So you'll have to check if CHPC has like a agreement or MOU or something like that with your institution or country maybe, and then see what resources they can then allocate to you. So we use it on a permanent basis. Yeah. Yes, yes. We're still getting the website up and going there. Currently, they're on our servers, but we're going to move the website, all of its components, to CHPC OpenStack.
Uh, yes. Uh, Thank you for the talk. It was super nice. Uh, so you say at some point in our presentation that OpenStack is actually used for HPC applications as well, right?
Sorry, could you repeat that?
So you say that OpenStack is actually used for HPC applications.
Yes, yes.
So is it possible, maybe you know something about that, but is it possible to use virtual machines and OpenStack to solve problems related to weight queue on Slurm? So just to give you context, I work in a project where it's a big company, and once a month they they have a peak of use and they have no resource. They have a big cluster and there is something that happens there. So once a month, no resource. And then I was thinking during your talk that maybe we could use some kind of oversubscribe with virtual machines to use OpenStack and virtual machines to actually use more the resource. We would probably delay the applications, but we would minimize the wait time in the queue. Do you know if there is any study or something related with that?
This is the moment where I say, let's go to the back and you can bludgeon me. Because I'm not honestly too sure about that. But what I can say is you can very quickly create a virtual machine with hundreds of gigabytes of space, for example. And then within the hour after you use it, you can then destroy that virtual machine or do whatever else pervertish things you want with it. So, yeah, it's OpenStack is there to very quickly give you resources and reassemble your resources.
Okay.
I don't know
Okay.
if I answered any.
Yes, we talk. We will talk.
Okay, cool.
Maybe you must look at singularity. Yes.
Hi, Kira. Thanks very much. That was a lovely presentation. Thanks for that question. It cleared up relationships. So basically, you're another department in CSIR, and you guys are doing an interdepartment relationship, right?
Yes.
So two-pronged question. It seems like your goal is to get rid of your hardware dependency.
Yes and no.
Okay. What's the no part?
The no part, you must always have a plan B, right? So
Right.
if CHPC is doing maintenance or something decides to go wrong on CHPC's side, of course, they are experts and they have redundancy as well.
Right.
But you never know what
Right. So
may
you-
have. So we have to have this thing called DNS switching, where we can switch between the downtimes of CHPC itself. Yeah, but
Okay, now thank
there's
you.
less of a risk using CHPC because our infrastructure is getting old.
Right. Now we can talk afterwards because we definitely got a use case, and my question would be, how do we get in on the action from the university side?